All right, here's the most basic circuit right here. You're not sure if you have 12 volts at the source, are you? Alright, so you want to be a little sneaky. You could actually take this. Bring this roll up. Because you don't know what's wrong. I don't know what's wrong either. Just go ahead. Use this. The bulb works, right? It's not the bulb. The real reason that I wanted to test that is because you agree with that. You guys agree this has a big source voltage and ground? How do you know? Because I made the bulb light up, so it clearly got.
Okay, they'll probably ask you for some keys.
So they're going to need a scan.
Definitely heard of me.
Let's explain why that are quite different types of
Okay, all right. Because I said, I know I should have that same water. Yes. And then I just put it right back. To the nerve. See if I can do something with us.
That's all right.
Okay.
I can move it. I'm not sure why nobody is.
Okay.
Go ahead there, Michael. This is a little, we can troubleshoot it like this, but I like to clean it up. I like to make it top to bottom, super clean, so we can make sure there's no shorts, right? All right, Michael, you want to use that fancy meter of yours, we can. Just a little early on it.
Did someone already get the keys for the bolt?
I have it already know what's wrong, I'm not going to tell you. Alright, source voltage equals 12.03. Very good. Let me drag this thing over here just a bit. I want to get this in a shot. Okay. Now, you know the battery's good. What would you test next? Now.
And then I get a scan tool.
Okay, here's, how about this?
Get that service
Hang your
mode.
black lead down there in the ground and leave it there. Don't touch it again.
Scan tool,
Now
right?
show me the positive
And
source
key.
battery.
Yeah, key and scan tool. That should be it for service mode.
Don't check that. I don't think it's there you go. 12 volts, good. How much is making it to the fuse? 12 volts, good. How much is coming out of the fuse? Oh my gosh! No volts. No volts. Let's tell you. The fuse is no good. Let's say they're going to be really bad right now. You want to jump it? Yay! But the fuse is blown. How the fuse got blown? I blame you. I blame you, dude. Yay! Or you want to use your meter in another way. Check resistance. Put it on resistance. When we do resistance, we have to isolate it from the circuit. Measure here to here. Oh well, what's that tell you? Idle limits. Bingo, which means kind of like it's an open circuit. Make sense? If you ask, close. Yeah, you could say that. That's like. And by the way, I glanced at this real quick, so just kind of knew what you had. Now look at it. I'm gonna get a new one. All right, the 10 amps are a little low. So you guys, let me ask you a question. What do you think about putting a 15 in there? It is a 10, so we shouldn't size it up, because the thing is, I don't know what size these wires are, but I think they're made for 10 amps, so we don't put a 15. However, we're low on 10 amps. I got a 7.5. You see the issue with a 7.5? Worst case, if this bulb pulls too many amps, it won't, because we can do the Ohm's law on this if we want. It won't pull more than 7.5. We can put this 7.5 in there, because we have enough. I would do it on Okay, so now if that's true, go ahead and measure your resistance. Alright, we've got wiggling around. Connections real quick. 0.3, 0.2. That's a good number. Okay, now let's reconnect it. And then I want you to do the available voltage again. Remember that first test? We had 12 volts here. We had 0 here. 12 volts here. All right, 12 in. 12 in and 12 out. Okay, now you know you fixed it. You kind of already knew because of the moment. So that's your basic circuit. Now we're going to pause and everybody's going to build a parallel circuit. All right, so here is your parallel circuit. Source, fuse through the fuse switch, down, doing a splice right there. Kind of a tee off to 2 loads. This one was perfect, very nicely done. Source through the fuse, going through, you can see from the side, no crossed wires, to the switch, through the switch. This point is that splice right here. Splitting off, both of these are getting their available 12 volts because they're in parallel. Through the loads, no crossed wires, to the ground. Okay, now let me test you. If I disconnect this, what do you think is going to happen? Both. Cool, you're right. If I disconnect this, what do you think is going to happen? 1. If I disconnect this, what do you think is going to happen? Both. Yeah, exactly. So if a customer came in with this concern, don't you waste your time telling me about the fuse, tell me about the switch. It's like, we know that this is a parallel circuit. Let's get down to business. It's either here to here, right? So if this one works, that tells you all this is good. The problem's got to be from here to here. Well, it's technically anywhere between here and here. Cool. If that bulb is out, you transfer that to here and you'd say, I might be losing it here. The bulb itself might be bad, or it might not be getting itself to a ground. Cool. So that's how you troubleshoot the parallel circuit quickly. Well, let's go see if anybody messed it up. Now look at this here. All right. Now technically, these were supposed to be loads. This is a load, but not the one that you could see as well. So there's your bulb and here's your fan. If I disconnect this, what do you think happens? Just the fan. Because look, it did, yeah, it just stopped. Because look, if you trace it, good. Right here still has its own source. This one doesn't make it lamp. See, it's a little confusing there, so I'm gonna move this the way I would do it, okay? Like this. This will make it a little easier to understand. Now you can see how it's open, right? It's going to the bulb, but it's trying to go to the lamp, and there's an open right there. That's your open circuit. Fix the open. Now it's working. Re-break it. Now it's stopped, okay? So, not bad. Cool. So you guys tell me, is this a series or a parallel?
Parallel.
I agree, because look, they all get their own source to the switch. Now you should really be grasping parallel. All you did was added another load in there. And this is a momentary switch, but it does work.
We had a normal one in there. We just wanted to see if that one worked.
So, what do you think happens if I undo this? Come on, little sweetie. How do you know none of them?
Because this is what connected to
So I really disconnected it like there, huh? This was the one that was coming in, so that's basically a disconnect at this point. Cool.
So now it just goes.
Right. So what if I were to do it like this? Because this is what you have to be able to do. Hold up. Don't you cheat.
Now this
You
one's gonna
guys
get power, but
predict
not the
it.
other ones.
Okay, you think this one's lit? You think those are not? Let's see if that makes sense to me. 12 coming in, 12 going out, 12 going in here, 12 dies here. Neither Neither of these two look like they're getting voltage. You want to test it? Push it, push it. Yep, you're right. Bada bing, bada boom. Now here's how I would improve on your design slightly. I think that I would actually probably put that one down as the first splice. Yeah, you pull. One hand. Put that one first. Okay, now at that point, that becomes this splice right here. This is like your base. This left one's gonna pull off of that, and the right one's gonna pull off of that. Cool, so there you go. If I pull this one, yeah, exactly. If I pull this one, what happens? Yeah, but you got to think about it, not just push the button. So you're working on understanding what the symptom would be. So when a customer comes in and they've got 3 lights and 1 light's out, you got to be like, well, I'm not going to bother testing the fuse. Why not? Because 2 lights work.
Yeah.
If it was the fuse,
None of them.
which is missing, but if it was the switch, then it'd be none, right? So we don't need to do the diagnosis up here. We need to start with that bulb there on the left, and so we're really only worried about this section right there. Does that make sense? All right, now you can make a fun circuit and we'll break it down. You guys, the assignment is try to make a series parallel circuit. We didn't learn about it, but make it series parallel. All right, here's the question. So this is upside down. A series parallel has a load in the series part and then load in at least one parallel set. So we've got going into the fuse, leaving the fuse. I'm just gonna make this make a little sense in my mind. And it goes through a load, right? The bulb.
Yeah.
It then leaves the load. The switch is kind of in a weird spot, but we could go with that. And then it tees off, and it does. You made your first series parallel circuit.
Let's go.
What happens if the series load goes bad?
The whole circuit goes bad.
Bingo. What happens if a parallel load goes bad?
Then the circuit's fine besides that one.
Just this one, yeah.
Oh, I don't know what that's about.
Whoa, that's interesting. It's still flowing through there,
But it's not on.
but
See?
these are sharing the voltage now.
Oh, so this
And
one's-
this one takes too much. It doesn't leave enough for that one. If you were to do a voltage measurement, you'd see that this is consuming a small amount of voltage, but not enough to glow. That one's pretty interesting. Cool, dude. But because we opened up the second parallel leg, that increases the amperage and that one will glow again. Kind of interesting.
lowered the resistance enough to.
Yeah, dude. Let's see. So you think this is series parallel, do you? Remember, a series parallel has to have a load in the series. I agree with you, this is series,
Oh, okay.
but there's
there should
no
be another
load.
one right
You
here.
need to have a load in there.
There should be another one right here.
Correct.
There should
All
be
parallel circuits start kind of looking like a series, but it's not a series parallel because there's no load in the series part. Okay, I agree. So I came back. You guys learned from your error. Yes, through the fuse, through the switch, through this first load. But wait a minute, this is bypassed. If you're gonna do it like this, it's gotta go through that first bulb and then split off. Make sense? How do you make it split off after the bulb?
No.
That's just a second. Let's trace it. See, it's easier to follow when it's facing the right way, right? So it comes in, goes through the load, tees into this. Yeah, that. Hey, what do you got going on over there? See?
Put it in the place where it should actually have power.
It doesn't make sense when it's all zigzagging all over the place. So this is a yes. Okay.
Now you connect the current to this one.
All right, so see, now I can see the stuff's not like going all crazy. All right, now why do you think these aren't doing much?
Because it's not grounded.
They are
it is
grounded.
They are grounded.
They are grounded. Remember, part of this is series. So this has to share with these two. These two are not getting enough because this one's taking too much.
It's wired.
No, the wire's okay. If you C has a lot of resistance. This is like the first sibling who's taken up a bunch of that money. This thing's gonna, if you wanted to measure this, you'd see it'd be consuming a lot. That's the challenge with series parallel. What other bulbs you have?
Ooh, none other. Way to borrow one.
Okay, I'll tell you what. Use that one. Let's swap out little bulb C with. That's okay. We can make it work. Just get it in place. Flip it 90 degrees. Perfect. Let's bring this one in here. Let's bring this one out of here. It's still not quite enough to get those to glow though, huh? Too bad we didn't have one with less. Yeah, it's just gonna consume too much. It'd be nice to find you another bulb. Okay, you got that small bulb? Grab that one. Switch this one out. See, once we knocked that one out, it was working. Switch that one.
Oh yeah, started over on
Okay,
this side.
watch this one. This one's gonna take some too.
Oh,
Okay,
zero.
so it's all about how much resistance each one has. It was flowing through that other bulb. You just couldn't see it because it wasn't enough amps. So yeah, that one's good. Very nice. You did what you were supposed to.
What kind of power brake booster you got on here?
But you'll understand. So this is the only actual series parallel you ever see on the car. And this dimmer rheostat happens to be bad, but the way it works, through the fuse, the rheostat is a resistor. So it's equivalent of this bulb that's in the series part. And that's going to take a certain amount of resistance, and that's going to basically make these bulbs either bright or dim. So they'd never put a bulb and then two bulbs, but they may put a variable resistor, such as this rheostat, and this functions as your dimmer. There's probably only one place you'll see that, and that's with your dashboard lights, especially on old cars. Other than that, we really do no series parallel with any regularity. But you guys built the only one that we do see. Cool. So that only series parallel is literally this system for adjusting the lighting on the instrument panel. Okay, cool, that's it.